Okay, last lesson we have started to talking about two terms, which is reduction and oxidations. Actually, it will be further explained or talking about reaction which are related to reduction and oxidations in Form 5. But actually, the basic concept of reduction, that is when we have metal oxide, when it return back into or form back into metal, we call it reductions. It is the origins of what reductions come from. And of course, the metal react with oxygens and become metal oxide. It is called oxidations. Okay, we have introduced these two terms. Okay, and that's mean extraction of metal ores. Now, sometimes it will also call reductions. Reaction of metal to form metal oxide, you can call it oxidations. Okay? Uh, and we also talking about the reduction of metal from its metal ores. Although we know that different metal use different method to reduce or to extract. Some metal we can use electrolysis. Some metal we can use heating with carbon. And some metal ores we use heating only. But we also introduce that because some metal the reactivity is higher than the others, we can use some reactive metal to reduce some less reactive metal oxide. Like this example. Okay, copper oxide. When we put some magnesium to it, the magnesium, like oxygen, the tendency of magnesium to react with oxygen is higher than that of copper. So the magnesium will take away the oxygens and become magnesium oxide. Okay, then the copper oxide is extracted or reduced. But of course, if you can choose, you will use magnesium to reduce copper oxide or use carbon to do so. Use Mg or carbon to extract or reduce CuO。如果俾你揀嘅話，which one will you choose? You need to extract a lot of copper oxide daily, maybe million tons every year. So, will you use magnesium to reduce copper oxide or use carbon to do so? Why?
Because it's a lot more common. And also it's a lot more cheaper.
Yes, much cheaper. Of course, carbon. Cheaper, much cheaper. Okay. So actually, we can use reactive metal to reduce or to extract less reactive metal oxide, but commonly we will not do so. But of course, for some special uses, just like what we end up in the last lessons，好似我哋上一堂最撚尾講到，有啲特別嘅用處就會咁做嘅。That is the reduction of iron-free oxide by aluminium. It is because we need these reactions, because this reaction can release a lot of heat, and the heat can melt the iron form to fuse the railway, to weld the railway line. I have explained how it works. Okay, when you cut the railway, how to fuse the two railway, the broken railway. Actually, we put some iron-free oxide with aluminum powder in it. Okay, raise temperature. The reaction will undergo this one. With a lot of heat release, the heat will melt the aluminum, the iron form. It will fuse the railway. Okay, it is much better than the other way to try to connect the railway. Okay. and in some cases, the reaction works, but it is not practical being used. Remember, we can use reactive metal to extract less reactive metal oxide, but it is not practically used. 其實一定係可以理論上可以用啲活潑啲嘅金屬咧，將啲冇咁活潑嘅金屬嘅 oxide 咧 extract 嘅，但係記住唔係常用，主要因為價錢問題。OK，so to explain the concept of reductions, actually the following reaction you know it. Okay, we extract metal oxide by carbon, but now we can name this reaction as reductions. It is extraction. That means form back to metal. It is also called reductions. Reduction means form back to metal, so the meanings are the same. Okay? But still remember, carbon cannot extract or reduce all metal oxide. It can reduce starting from zinc oxide, and the reactivity is lower than zinc. They can all be reduced by carbon. Okay? No reactions for reactive metal. All of those below, they can. But of course, mercury dioxide, and silver oxide, because we can extract or reduce by heating only. So, we usually do not require adding carbon to it. Okay? And we are going to talk about the last reaction of metal. It is the fourth reaction. The fourth reaction. What we are going to learn, only 4 reactions for metals. The first is reaction with oxygen. Second?
With carbon.
No.
Water.
With water.
One with hydronic acid.
The third?
With acid.
With acid. And the fourth, it is called displacement reactions. In Chinese, 置換反應. What is displacement reactions? That is, a reactive metal displaces the compound of less reactive metal. Similar to what we have already learned, the reduction concept. Reactive metal can reduce less reactive metal oxide, but not only oxide. If the less reactive metal is other form of compound, usually solution, then we put some reactive metal, more reactive metal in it. The less reactive metal will be displaced. That means the less reactive metal compound will form back to metal, and the more reactive metal will replace the positions of the less reactive metal. Okay, the following is one of the example. Comparing with the reactivities of copper and silver, which one is more reactive?
Copper.
Yes, the reactivities of copper is higher than that of silver. Okay? Then if we have a compound, which is silver compound, like silver nitrate. But actually, in laboratory, silver, we have only one compound, that is silver nitrate. Always silver, then nitrate. If we have a solution of silver nitrate, if we put a piece of copper in it, yes, the Cu will replace the silver ion positions and become copper nitrate.
Whoa.
And the silver is being displaced back into the element.
So
Just like the copper displays the position of silver, so why this kind of reaction is called displacement reaction. Yes. Yes. In Chinese, 雀巢溝戰反應其實唔會咁寫 sorry. Okay. It is called displacement reactions. And it is quite interesting because the observations originally silver nitrate do not have any color. So you put a piece of copper into a colorless solution. But lately, the copper displays the position of silver and becomes silver nitrate. Then it presents copper ion. And still remember the color of copper 2 ion? Blue. So the solution will slowly turn to blue. And of course, the silver will form. And where will the silver form? It will form on the surface of the copper. So you will see some gray solid form. Actually, it is not quite accurate. It is not shiny silver. Not shiny silver. Usually it is gray color. Why? Because it will not form regularly, very smoothly. It will form in particle form, so it will not show a silver color, but instead gray color solid form. Such kind of reaction will occur when you put a more reactive metals into less reactive metal compound. So the other example including if you put iron into copper 2 sulfate solutions, then the following reaction will occur. First, this iron. Okay, sorry. The iron put into a less reactive metal copper sulfate. It will replace the position of the copper and become iron 2 sulfate. Remember, when iron reacts with acid, it will form iron 2 iron first. We know that iron has two kinds of ions, but usually iron in acid or in displacement reaction, it will form 2 plus first. You lose 2 electrons and then you lose the last one. So the first step, it will form 2 plus iron first. Yes.
咁 displacement 係咪淨係喺 nitrate 先會發生啊
No, it is sulfate. The second example is nitrate.
？nitrate and sulfate。
Actually, only when the ionic compound can soluble in water, the reaction can occur. It can be sulfate, nitrate, chloride, bromide, iodide, etc. The salt itself, the ionic compound itself can soluble in water. Then it can undergo. Okay? So you can see the Fe become Fe2 plus and forming the iron 2 sulfate. The copper form back to copper metal. So it is also called a displacement reaction. And can you write down the observable change? The color of the solution turns from blue to what? Originally it contains copper 2 plus iron, so it is originally blue. Then finally the copper ion will be removed. The color of the solution will no longer blue color. But we have some iron 2 ion formed. And still remember iron 2 ion, the color?
So
Pale green. So the solution turns from blue to pale green. The color of the solution turns from blue to pale green. Color of solution. turns. That's been changed.有咩關係啊？一開始其實你個 reactants 度個 solution 有咩顏色？Because in the reactants we have only the solution contain copper 2%, so it must be blue in color. And finally, because it will form the compound iron 2%. What is the color of iron 2%? Copper removed, no longer blue. Forming iron 2 iron, it is pale green. So it changed from blue to pale green. Yes. And because some copper will be formed, so what is the other observations? Brown solid form. You will have the chance to do the experiment, okay? You can observe the color change, but it's better try to guess the observations by looking at the equation itself. I will give you some other example. I will ask you to try to predict the observations by yourself. Okay? There are two examples. Can you suggest other example that displacement reaction occurred? 好啦，問一個簡單問題啦。頭先係兩個例子啦，可唔可以舉到一啲其他例子啊？你講咗先，我講完再問大家得唔得？咁呢一個嘅 potash 加個鋅嘅 ionic structure。是但俾個 N 啦，佢鋅乜嘢？nitrate 又得，sulfate 又得，chloride 又得。sulfate 啊。先 sulfate。OK。變 potassium sulfate 加鋅。Okay, very good suggestions, but I will ask all the rest of the tasks. Do you think it is okay? No. Okay. Does it okay? Will it undergo displacement reactions? And other suggestions? 舉多幾個例子先，每一次唔好淨係睇呢個先。Either one reactive metals putting into a less reactive metal compound. Sodium. In iodide. Tin. Tin iodide. Tin, the formula of tin is Sn. Iodide is I. Tin has a charge of 2 plus. Tin iodide solution. To illustrate, it is a solution because usually displacement reaction occur in solutions. So I put the tissue stage to show that it is a solution. Other example, other suggestions? Choose either one metal which is a higher reactivity series and one with a lower reactivity in the reactivity series, the compound of the lower reactivity metal. Any suggestions? There are so many metals in the series. Can it be zinc combination with silver? Can it? Okay, zinc. Silver. But silver usually silver nitrate. Other combination? Some combination? Either. Just looking at the reactivity series. Choose either metal the higher positions and either metal with a lower reactivity series, lower positions. Magnesium and what? Copper sulfate. Copper sulfate. Very good. Okay, let's check up to now first. Okay, I can say that some of the reaction, yes, it is displacement reaction, but some, no. Not means that they will not undergo displacement reaction. The combination is what? The metal is more reactive than the ionic compound, but if it is in a situation of a solution, the displacement reaction will not occur. It will undergo other reaction instead of displacement reaction. Do you know why? Two of the four reactions, they will not undergo displacement reaction, but instead they will take place other reaction instead. Do you know why? The four suggestions, the four reactions, there are two reactions will not undergo displacement reactions。四個之中，我兩個唔會進行 displacement reaction，唔係代表個組合唔啱。而家係一個活潑啲嘅金屬擺咗一個不活潑金屬嘅 compound 裏面，理論上會 displacement reaction 嘅，但係頭先我冇提到，有啲組合咧唔係好 OK 嘅，嗰啲組合主要就係啲 metal，they are too reactive。Yes, why they will not undergo displacement reaction?
因為爆炸。
Not 爆炸嘅。
It will react explosively.
No, not explosively, vigorously, but will it react with this iron? No. There are water in it, and the metal will react with
the water.
Yes, it will not react with this one. It will directly react with water. And form what? And form KOH and H2. Okay, instead of undergo displacement reaction. So usually displacement reaction, we will not use potassium, sodium, and also calcium. These three metals, they are too reactive. They will directly react with water instead of the less reactive metal to undergo displacement reactions. If you compare, you have two reactions you can undergo. You will take place the reaction which will react faster. Because the reactive metal, they will react with water faster, they will undergo the reaction with water instead of the reaction of displacement. Okay? So usually displacement reaction, we will not use potassium, sodium, and even calcium. Starting from zinc, yes. So can you expect the product form?
Zinc nitrate.
Zinc will form zinc nitrate. It is easy. Just repeat the position here. But be careful. Zinc, what is the charge of zinc? Iron. Yes, zinc is 2 plus. What is the charge of nitrate iron?
1 minus.
1 minus. So what is the formula of zinc nitrate form?
Cn 開括號 nitrate 三括號 2.
Yes. And the other product is?
2 silver.
咁快寫埋 2 silver。我冇得慢慢嚟咧，我哋要慢慢 balance。Silver. And how to balance the equations? 邊個寫嘅 2？A 寫個 silver nitrate 寫個 2，仲有咧 ？A 寫個 2。Okay, balance. So this reaction will it undergo? Yes. If you put zinc into silver nitrate solutions, it will undergo the following reactions. But what is the undergo? What is the color of this one? Colorless. What is the color of this one? Colorless. So, will the solution change color? No, but you will observe some not white, gray solid form on zinc. Okay? Gray solid form on zinc. Okay, similarly, for the next reaction, what is the equation? What will be formed? Mg, what is the charge of Mg? I. 1 plus. 2 plus. Group 2, 2 plus. How about sulfate?
Sulfate 都好似 2 plus.
2 minus. So the formula of MgSO4 is MgSO4. And what will be formed? Cu.
Balance.
Already balanced. Okay? But can you guess the observable change?
係咪有呢一個嘅 blue 變成 colorless？
Yes, because copper sulfate originally is blue, and this one no color, colorless. So when you are going to write down the observable change, just expect the original the solution is blue and decolorized. Okay, or turns to colorless. The solution turns from, we usually use turns to describe changing of color of solutions. Turns from a color to another color, from a color, the original blue, to colorless. Okay, it is the first observable change. And a solid will form. What is the color of the solid? Copper, originally it is. Copper is the only two metal which is not silver color. It is brown in color. So the second is brown solid form on Malaysia。佢會喺個 Malaysia 上面 form 嘅，因為其實實際發生反應咧喺個 Malaysia 表面度發生，喺嗰個位置大家交匯咗。Okay, so I cannot show all the possible reactions. There are 4 examples you can see. Any combinations from the metal reactivity series except for these 3. You can use to displace all the other metals in lower positions of the metal reactivity series. Okay? So I will not show all of them. But it is more easy than the other 3 reactions we have already learned in this chapter, right? Okay? 咁呢個就叫 displacement reaction 啦。其實咧，我有畫圖嘅，不過個圖咧可以望翻下面啦，喺第15頁嗰度。咁呢幅圖咧就解釋咗咧啲 reaction 發生嘅時候咧顏色轉變啊，其實點解會咁啊 ？OK。好啦，今堂咧仲會學多一樣嘢嘅。咁點解學呢樣嘢咧？主要就係 actually why we need to learn this one. It is called ionic equations. We already learned to write down quite a lot of equations. We have learned how to write down the equations of the reaction between metal and oxygen, metal and water, metal and acid. We also already learned the equations of displacement reactions. But especially for the displacement reactions, the equation itself cannot show what had been happened exactly in the solution. 其實我哋發覺咧 ，equation 本身咧就講咗好多資料嘅，但係有陣時有啲 equation 咧，我哋會覺得佢唔能夠將實際個反應、真實個發生咩事講出嚟，所以咧有陣時我哋需要借助寫呢個新方嘅 ionic equations 咧，嘗試令到大家更加清晰。So actually, ionic equation is also equations, but it is a simpler form of equation to help us to know exactly what had happened in some kind of reactions. 有部分嘅 reaction 我哋想要知道真正佢發生緊咩事，我哋會將佢變做一個叫 ionic equations。咁in this chapter, there are 2 reactions. We can change it into ionic equations, including the reaction of metal with acid, and also displacement reaction. We both such 2 kind of reactions, we can rewrite it into ionic equations. Can I erase the white box? Metal plus exit. Okay, the third form of equations and displacement reaction. We can remember our only equation is a simpler form of equations compared with what we have already learned the equation itself. Okay. Why we need to rewrite in the other equations? Try to track exactly what had happened in the reactions. So we try to remove those substances which are not actually included in the change itself. 其實所有 equations 咧係一個簡化版本嘅 equations。我哋想要令到大家更加清晰地知道個反應裏面發生嘅咩事，所以我哋會將一啲唔相關嘅嘢，即係喺個反應過程中其實冇參與反應嘅嘢，將佢清除。嗰啲冇參與反應嘅嘢，我哋叫佢做 spectator ions。rewrite 留意下，其實佢哋全部都係有 equations 嘅，but we can rewrite into ionic equations. Ionic means that the equation will show two ions, not ionic compound. The ionic compound will be separated into separate ions and remove spectator ion.
呢啲全部都係 ionic reaction 嚟㗎，係嘛？
咩全部都係 equation？
metal 任何 reaction 都係。
No. What we have already learned in these chapters, 4 equations, only the reaction between metal and acid and displacement reaction can be rewrite into ionic equations. 金屬同 oxygen 嘅反應冇得 rewrite 嘅，金屬同 water 嘅反應都冇得 rewrite 嘅。OK， 係 metal reaction effect, metal displacement reactions, they can be rewrite into ionic equations. 其實最重要嘅步驟就係清除 spectator ions。What is spectator ion? In Chinese, spectator 旁觀。
即係唔關事嘅，即係完全冇反應。
Yes, it does not change. 旁觀的例子。So why are some ion is spectators? Let's looking at a aqueous solution of ionic compound.
ionic equation 係關 ionic bond 嘅。
Aqueous solution of ionic compound。其實最重要嘅問題就係 when we have an aqueous solution of ionic compound。What happens when we dissolve some ionic compound into water? For example, if we put copper sulfate into water and become copper sulfate aqueous, what happens in the solutions? We know that ionic compound, it contains cation and anion, and cation and anion. Okay? They form a crystal. The cation and anion, they bond to each other firmly. But what happens when we put an ionic compound into water? When we put it in water, we have many water molecules. Then the ionic solutions will become like this. The cation, the anion, they are separate. 其實我哋將一個 ionic compound 抌落水嘅時候咧，就會出現呢個問題。原本 solid form 嘅 ionic compound 咧，我哋上嗰幾課學過啦。We know that they form a crystal. The arrangement of cation and anion adjacent to each other form a crystal level structure. But when we dissolve an ionic compound into water, the cation and anion, they will separately present in the solutions. far away from each other, they become separate. Okay? So, if there is any change related to the cation, the anion, they will not change at the same time. 其實我哋發覺咧，當一個肯定 compound 喺水嘅時候咧，佢個 cation 同 anion 咧，我哋就話佢係 separate 嘅。Ions are separate.
咁正常會用邊一個？
It depends on what is being or what will undergo reactions. For example, for displacement reaction, the actual reaction is the cation, so the anion is spectator. They are separate and will not undergo any reactions. Okay, so for example, copper 2 sulfate, we have a copper 2 plus ion and the set anion SO4. But they are separate, so only the copper 2 plus ion react the sulfate ion, no change. So in such situations, the sulfate ion is called spectator ion. It will not undergo any reactions. It will not change. When it will not change, why we need to show it in the equations? The equation is showing what is changing in the reactions, but it will not change. So we can remove it, or we can ignore it in writing down equations. Okay? So when we have an equation like this, copper putting into silver nitrate solutions, we know that silver nitrate is a solution. That means the silver ion and the nitrate ion are separate. And who will undergo reactions? Only the silver ion. And finally, it will become copper 2 nitrate. It's also a solution. Okay? The nitrate ion does not change, so we can remove it. So when we rewrite it into an ion equations, it will become like this. The nitrate ion from the start and end of the reactions, it does not change. It's still a nitrate ion. In the solution, it separates from the silver ion and NO3 minus ion. In the final solution, it separates from the copper 2 plus ion and nitric 3 ion. Original, from the start to the end, no change, no reactions, and they are separate. So we remove it from the equations. So we can only write down the silver ion and the copper ion at both sides of the equations.
嗰個議程嘅調翻上。
其實主要個 charge 要一樣咯，前面有兩個一正，後面有一個二正。Okay? So how to rewrite an equation into an ion equation? Usually the following step you can follow. First of all, write down the original equation first. And then try to indicate which substance is a aqueous solution of ionic compound. Try to separate the two ions. Okay, 2 AgNO3 means that there are 2 Ag plus and 2 nitrate ions. And copper nitrate means that it has one copper 2 plus and 2 nitrate ion. Okay? Then, after we separate the ionic compound into two separate ions, you can see on the reactant side, on the reactant side, there are 2 nitric ion, and on the product side, also 2 nitric ion. No change, right? So we can remove it from the equations because there is no change for the nitric ion. And we obtain the final equations. Why it is called ionic equations? You can see there are ion present in the equations. So it is called ionic equations. But after rewriting into ionic equation, you can clearly know what is happened in the displacement reactions. 睇個 ionic equation 咧，我哋而家更加清晰地知道發生嘅咩事。你可唔可以試下幫我簡單地覺得究竟呢個 reaction 發生嘅咩事？ When we put copper into silver ion solutions, what's happened? According to the exchange of electrons, what's happened? What's happened? The copper gives electrons to the copper. Give electrons to the 2 silver ion. And on the other hand, you can say the silver ion gains electrons from copper. Actually, it is an exchange of electron for a more reactive metal to a less reactive metal ion. It is the real things or the situations of displacement reactions. So after you know how to, or you know the concept of displacement reaction is actually the reactive metal gives electron to the less reactive metal. The above procedure, you can ignore it. No need to rewrite it into ionic form and then remove the separate ion, the spectator ion, and then rewrite it. 去到你慣咗咧，其實你明白個反應本身咧，其實你直接寫 ionic equation 應該都得㗎。不過我哋要試下 practice 下，我用下舊方法 practice 同埋新方法 practice 下。So help me to rewrite the following displacement reaction into ionic equations.
N I 即係通常如果係刪除個，即係如果變成 ionic equation 嘅話，係咪一定會刪除個 N I 啊？
因為 N I 其實就係 spectator。
即係一定係會，一定會。
Yes. Okay, try to rewrite the 2 displacement reaction into ionic equations. You can use the method taught in the notes, or if you understand the concept of displacement reactions, you can directly write down the ionic equations. OK， 如果跟notes 嘅步驟就應該咁寫嘅。首先就係將ionic compound aqueous solution 拆開佢，咁所以咧呢個唔使拆啦 ，Zn plus Fe 呢條幾正啊？2 plus。 SO4 幾多負啊
1 plus
？2 minus。
2 minus yes，我成日都知啊。
隔離咧，升收肥咧，
升收係
都係升2 plus
係
SO4
1 plus
2 minus。
2 minus。
跟住個 metal 就唔使拆啦。咁啊，邊個係 spectator 啊？邊個 unchanged on left side and right side？
SO4
sulfate。
sulfate。
And then we write it. And zinc plus Fe2 plus form zinc2 plus Fe.
都唔係好難啫，呢個。
Okay, similarly for the second equation, second example. This is the first, this is the second. How do we write it? The first step is separate the ionic compound in solution form. Does it require to separate? No. Does it require to separate?
Yes.
How?
You first take
2 silver, how many charge?
1 plus.
2 silver, 1 plus. And 2 NO3, how many, what is the charge? No. Nitrate is 1 minus.
Oof.
Similarly, for the right side, form, what is the charge of PB? Iron. 2 plus.
PB 係咩 platinum。
And what is the charge?
Iron lead。
There are 2 NO3 minus and 2 silver. So which ion is spectator?
The nitrate.
The nitrate.
Yeah.
So remove it. We write the equation and it becomes Pb plus 2 silver iron and form Pb2 plus 2 silver. Okay, after looking at 3 examples, can you rewrite the equation in a more faster way? Can you rewrite the following equations by
Yes.
more faster way?
3
3, the third example.
Okay.
We use, for example, magnesium. Magnesium plus silver nitrate. The original equation is 2 and becomes magnesium nitrate and 2 silver. Can you rewrite it?
Yes.
Immediately without writing down 3 equations?
Yes.
So, magnesium is magnesium.
Mm-hmm.
NO3 remove.
Mm-hmm.
So leaving what? 2
2
silver
Ag plus.
plus. The nitrate must be removed. So the nitrate must be removed, leaving
Mg minus 2.
2 plus.
係 2 plus.
And 2 silver. After you know the concept, no need to rewrite it into 3 equations. Okay, just remove the ni. But remember, one thing you must check. You must check the total charge on left side and right side. They must be the same because remember the equation just like the equation in mathematics. All things should be equal on both sides, including the charge. So there are 2 plus charge. Must be 2 plus charge on the right side.
Yes.
Okay? Be careful. But I told you that there are 2 equations. They can also be rewritten into other equations. Not only displacement reaction, including metal reactive reaction. Do you know why?
I don't know. Why?
係咪因為乜都變？
Okay, let's check. Let's review some of the reactions we have already learned in the previous lesson. We know that magnesium adding into hydrochloric acid will form what?
MgO.
Must form H2, right?
Yeah.
And
magnesium.
Magnesium will replace the position of hydrogen and form compound with chloride. So what is the compound? It is MgCl what? 2.
因為 CL 係 one
Okay, it is the equations of magnesium react with hydrochloric acid. And this equation we can also rewrite into an equation. Do you know why?
都冇 observe 啊。我唔要個 magnesium 啊。
No. First of all, this compound, it is aqueous form of ionic compound.
Yes.
So they can be separate. And what is an acid? An acid is a compound with hydrogen, and it dissolves in water. It will become hydrogen ion and corresponding anion. So this equation is actually similar to the dissipation reaction.
係得嘅咩？咁呢個咪麻煩好多。
Which ion is spectator?
Hydrogen and chloride.
Which ion is spectator? Chloride ion only. No. Can you understand what exactly happened when metal react with acid?
Yes.
Actually, the metal loses electron to
the ionic bond.
No, the magnesium loses electron to what is it? It is called hydrogen ion. The hydrogen ion gains the electron and forms back to H2. So can you rewrite the reactions? Into ionic equations.
咁咪 SO4 係 spectator，and then Cn 加 zinc 加 hydrogen 2。
The reaction is zinc plus how many two hydrogen ion? 2 hydrogen ion will form to zinc 2 plus H2. Do you think the ionic equation is much simpler than the original equations?
Yes.
And do you understand what exactly happened?
Yes.
Actually, metal react with less reactive metal. It is the process of the more reactive metal losing electron to the ion of less reactive metal. So it dissipates its positions. Similarly, metal react with acid. It is the metal losing electron to hydrogen ion in acid. So the hydrogen ion, while forming hydrogen gas, because the hydrogen ion gains electron, it will form back to the original gas hydrogen. And the metal form is corresponding and cation. Rewriting of an equation into ionic equations will be asked in the examinations. But it is easy, right? Actually, it's quite easy. Quite easy. Okay? And we almost finished this chapter.
So we finished.
But we still have 2 chapters to go.
下堂做實驗得唔得啊？
考堂測驗，測驗同埋完成埋嚇。
測咩啊？
都話星期2有健康測驗嘛，所以聽日測嘛。
哇！下堂測咩啊？
狗嚟嘅呢個，呢一個人啫嘛，真係唔好休息啊！
Okay, remember tomorrow you will have the test of chapter 8 and 9.
爛你個頭啦！
Okay, do some revisions. Okay, see you
你
tomorrow.
測驗唔合格，你一陣又叫晒成班同學。
咩上所有料？我俾你1分鐘，30秒。
呢度咁啊，我都特別，我將我都非要交。越嚟越多唔錯。
13秒。
你今日要打波。